Submarine gliders make it possible to collect physiochemical data such as temperature, salinity, and oxygen levels from the sea in an autonomous and continuous way at a high spatial resolution. So SEAB has a fleet of gliders taking samples continuously in the Mediterranean Sea with the objective of obtaining data, so its characteristics may be studied and small-scale variability solved. But do you know how a glider works? The glider is ready to start the mission. The sensors and the navigation and flotation mechanisms have been checked. Inflating the bladder allows the tail to rise up and receive the operator signal. The commands which initiate the mission can be received either locally from a vessel or remotely via satellite. The computer, located in the navigation bay, calculates the course to start the mission. At the same time, the scientific bay receives the configuration signal and prepares the specific sensors for sampling. The computer, located in the navigation bay, gives the command to move the battery towards the bow and retract the piston, which will permit immersion to begin. During the immersion, the glider is set to collect scientific data. The CTD allows depth and salinity measurements to be made. The fluorometer allows chlorophyll levels to be estimated. The oxygen sensor determines the concentrations of this molecule in the water column. All the data recorded by the sensors is stored on a hard drive. During the immersion, the navigation data is also registered. In shallow waters, the altimeter is used to avoid collisions with the seabed. When the seabed is detected or the depth objective is reached, the navigation bay gives the command to start the ascent. During the ascent, the glider continues to collect data measurements for temperature, salinity, and chlorophyll. The glider makes ascent and descent movements in the water column of between 0 and 1,000 meters, on missions which can last up to 2 months, covering 24 kilometers a day in any meteorological conditions. In the case of an emergency or at the pilot's request, the glider emerges to communicate with the base. The bladder inflates once again to receive the operator signal. The glider transmits all the data collected, receives updates for the mission, and uses GPS satellite positioning to calculate its new trajectory before starting a new immersion.